Hey people, so I wanted to make this quick video to share with you some responses for the distance learning lessons for this week. Now, I have my headset in. I know it looks a little awkward because I don't want to have any feedback on the mic. Sometimes if I record without the microphone, you can hear a lot of stuff, including my dog barking and whatever it is. So, in any case, day one and day two, you had to do lessons 2.1 and 2.2. Now, in these review videos, they are going to be a little long because I want to discuss with at least some depth some of the questions which I think really require you to think critically, to analyze the situation, to identify what the relationship may be. And so I'm going to even go ahead and read the information to you. It says, in the last investigation, you examined linear relationships. For example, the distance d a person walks at a constant rate depends on the amount of t time that they have. Now, you always want to make sure that when you're going over these things, these lessons with me, if it's not a Zoom or a Google Hangout when I'm going over them, that you have obviously not only the screen open, but you giving yourself an opportunity to really like look at your answers, and then jot down any questions that you might have for me that you can pose in the Google Classroom or just email me directly. In any case, the amount of money a person raises from each sponsor depends on the distance walked for the marathon, and the relationship shows like that. So that's what we focused in on. But then now in this investigation, we're going to continue to solve problems involving walking rates and other linear relationships. So before we left, we did that work in investigation one. And so investigation two, it says in Miss Cheng's class, Emil found out that his walking rate is 2.5 meters per second. I'm going to go ahead and below write down that just as a proportion, 2.5 meters in 1 second. So that's clearly a unit rate. And that is for every 2.5 meters, he walks 2.5 meters in 1 second. He gets home from school, he times his little brother, Henri. And as he walks 100 meters, now he figured out that Henri's walking rate, he's going only 1 meter in 1 second. Now that's an interesting proportion in itself. And so Henri challenges Emile to a walking rate. Oh, I'll put my screen down. Sorry. He challenges Henri to a walking race, but because Emile's walking rate is faster, now he's covering more ground in the same amount of time, right? And this is Henri's right there. So he's covering more ground in the same amount of time. He wants to give him a 45-second head start. Okay. Because he knows he wants his brother to enjoy winning the race, but he doesn't want to make it so obvious. Okay, great. No problem. So here's what I notice with this problem, because it's only one particular problem you're asked to find, really. How long should the race be so that it's close? And to describe a strategy for determining the race. Now, what I will tell you right now is that working backwards is in fact one of those things that you want to do, because here's what we do know. We do know that Henri is going to win the race slightly, but Emile wants to be very, very close to him. So here's my little picture of Emile and Henri. Here's big brother, here's little brother. Okay. And then we also know that he's going to give him a 45-meter head start. So here's the start of the race. And who's going to get that 45-meter head start is going to be Henri. 45 meters. Okay. So here's what you then should have done: made a table, made a chart of 45 meters is where he's going to be of a start, right? 45-meter start. We're not saying a certain amount of seconds start, a 45-meter start. So that's where Henri is, and Emile's going to be right here. They are going to start at the same time. So that's also important. They're starting at the same time. He's just giving him a distance ahead. He's saying, go on and go to the 45-meter mark. But at some point, we're going to meet up and I'm going to almost catch you. And so the answer key says that the race should be 75 meters or more, because what's going to happen is at about the 30-second mark, is when they'll be neck and neck. Well, how is that going to be? Well, if Henri goes 1 second per meter, 1 second, 1 second, 1 second, 1 second, 1 second per meter. And so if he already gets 45-meter head start and the race is 30 seconds in, he's going to be at that 45 meters plus the 30 meters he's going per second, right? So that's 75 meters. Now, his brother Emil, on the other hand, he's not getting that head start, but he's going 2.5 meters per second. So 2.5, 5 meters, 7.5, and so on. And so what's going to end up happening is after some time, he's not only doubling Henri's distance because he's going 2.5 meters per second, doubling and a little bit more. So again, the answer is the race should be about 75 meters. I don't want to take the time to make the table, but again, you making a table, you could have done it in Google Sheets to show, what is it at zero, at time value 0. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For Henri, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 per second, but not really because you're adding the 45 meters to it. Oh, I have a visitor in the office. Say hello to the people, Zimbabwe. Okay. All right. All right, moving on. Now I'm going to go ahead and for problem 2.2, actually show you the answers from the answer key in the math dashboard because not everything shows up on this document for whatever reason. So in your lab sheet, it did show the actual work. Let me see if I can get to it. That's distance learning. Give me 1 minute. Okay, so this didn't copy for whatever reason in the PDF file I have, but it says your class found some interesting strategies, making a table, showing time and distance, graphing the distance for both brothers at the same set of axes. And again, I can go into further detail and depth on this if you guys really need it, but really looking at making a table, you can graph that information. Maybe what I'll do is I'll insert a table in Google Classroom so you can see it. But in any case, what you then had to do for this particular problem is you had to complete the table showing the distance from the 0 to 40-second mark in 10-second intervals for each brother. So I wanted to show you what they have. So that's the answers you should have had for answer A1. And then if you look, it says on the table, the length of the race ends at 75 meters. Okay. And that's the 30-second mark. And their distance is exactly then the same. So it needs to be under that amount. Okay. And if you did your graph properly, it should look like this. Okay. I want to go to the document that you all have that you're typing your answers in just to make sure, because some of the questions I didn't have you do. Okay. So, and I started writing in some of these answers, but I figured it would take me a lot longer to sit there and write. So writing the equation to represent the relationship between time and distance, what information each variable and number represents. And remember, with the video, obviously, guys, you could pause it at any point in time. So you don't necessarily need me to, you know, take such a long time with the answers. But on the graph, when you look at it, the length of the race ends at a tie at 75 meters. This happens to be the point where the two lines intersect. Because the two lines intersect, we actually call that the point of intersection. So the coordinates of that point happen to be 30, 75. For Henri to win, the length of the race should be slightly less than 75 meters or 30 seconds long. And so they showed us that. And then here's your equations. Distance for Henri is 45 plus time times distance. And then Emil is there as well, and you can see it. Okay. And when we look at this, the reason why that 45 is there is because it's that 45-second head start, remember? So now I look at time and its distance, and we know that it happens to be 1 second, 1 meter, and so on. So that's why it's easier. For Emil, it's 2.5 times whatever the distance is going to be. He's going 2.5 meters is his time times whatever the distance is going to give us what his amount is, okay? The walking rate shows up in the graph as the steepness of the line because the question you were then asked, and again, I'm just toggling back and forth so you guys can see, the question you were then asked is how does the walking rate of each brother show up on the graph, the table, and the equation? And so that's number 4, okay? And so that's this right here. And let's see, maybe I'll do this. Maybe I'll go ahead and copy this. It's distance learning. Did I make this the answer key? All right, so sorry, I knew I had a document that I was titling answer key, but I definitely didn't want to put the answers in the wrong spot or put it in the spot. In any case, let me just go ahead and continue on and show you guys the answers here. B1, I believe I had you do. And so take a look at that. And B1, you were answering how far can or does Emil walk in 20 seconds? And so it says 50 meters. And we know that because it's 2.5 meters per second. Okay, so in 20 seconds, he's going to walk 2.5 times 20. And sorry, I don't know why it's like the answers are scrunched up. Okay, B2 was after 20 seconds, how far apart are the brothers? How is this distance represented in the table and the graph? So in B2, 15 meters. After 20 seconds, the brothers are 15 meters apart. 20 seconds, Emil's walk 2.5 times 20, which equals 50. And Henri has walked 65 meters from the starting line. And so we're looking at that. Okay. Now you could also look at your graph to see how the two values and the distances that they are apart. All right. And 3 is the point 2670 on either graph. Well, let's look on the graph. Do you see it? 26 here, 5-ish, 70. Is it on either point of the graph? And they mention no. And they mention no because if you substitute 26 for t in time, and on Henri's, you're going to get 71, not 70. And if you substitute t in Emil's equation, you get 65. So it's really just replacing the variables and putting one in the other. And after 75 meters or after 30 seconds, that is the point in the table where the time and distance for the brothers are equal and the point of the graph where the lines cross. Okay. And then C, let's take a look. You guys were asked, how can you determine which of the two lines will be steeper from a table from an equation? How can you determine which of the lines will be steeper from a table and an equation? In the table, the line is steeper if the rate of change is greater. Obviously, if you have a greater rate of change, it's going to be steeper. In this case, it's the walking rate. In the equation, the line is steeper if the coefficient or the time. Okay, and then let's go ahead with D1. At what points do Emil and Henri's graphs cross the y-axis? What information does this give you? Okay, so at what point do Emil and Henri's graphs cross the y-axis? Well, Emil's line crosses the y-axis at 0, Henri's 0, 45. Now, that's a weird question. You might think, well, Ms. Conte, what do you mean by that? The y-axis, isn't this the y-axis? So where do you see Emil's at the y-axis? At 0, 0, right here. Where do you see Henri's at the y-axis? At 0, 45. Remember, he got the 45-second head start. So that's what that is. And I know that some of you probably maybe looked at it and said, this isn't quite clear, but that's what that means. And then lastly, what information do these points represent in terms of the race? D2 and D3, how can these points be found in the table and in the equation? Well, what do the points represent? We know the points represent each brother's starting point because that's where they started, right? 0, 0, and then 0, 45. We weren't thinking about any time, but we did have some distance for the younger brother, Henri, and then Emil started. He didn't have a head start. And then in the table, you find the distance value when time is 0. In the equations, it is the value of D when t equals 0. So if there's any further questions, please, again, put them in Google in the Google Classroom. What I'll do is I'm going to scroll through these one more time just so you can get them all. The table that you had for A1, we know the length of the race ends in a tie, I guess, if it's at 75 meters, and that's their point of intersection where both of them intersect. Okay. And then on the graph, it shows the length of the race ends at the 75 meters. We talked about that being the point of intersection, 30, 75. And if you remember, the 30 represents time, because that's one of the variables or values in our graph, and then distance, 75. And so that was 2.1's kind of how you find it out. Then here's your equations for the two. Okay. So the distance for Henri is 45 plus time. And so that's the amount of, seconds, because we know he's 1, 2, 3, 4, 5, 6, 7. So his distance is 45, and you're adding 1 second, 1 more meter, 2 seconds, 2 meters, and so on. Emil, different scenario, because he's going 2.5 meters per second. So his distance, this should be separated here in this answer key. D for Emil equals 2.5 times time. Okay, and D is the distance from the starting line. Okay, and then B1, 50, B2, 15 meters. Okay, and you can see the answers. And I know the answers, they were pretty long answers in the answer key here on Math Dashboard. And so when I make them into lab sheets, I really just want you guys to sometimes focus on the math, but really being also able to explain how the answer is or why the answer is. So right now is a good point, if you haven't written them down, the answers down, to write it down, but really just to take a second to really read a further, more detailed explanation. Okay. Hopefully this helps a lot. And I'll be in touch pretty soon.